All right, welcome everybody. Looks like we got some participants joining, so we'll wait here just a minute as people join, and then we'll get going. Okay, we'd like to welcome everybody to our webinar today. We're very excited to do this presentation. Looks like we've got lots of people joining in and continuing to join in, but we'll get started here right at the top of the hour. My name is Josh Parker. I'm the marketing director here at Melford Borzall, and we'd like to welcome everybody to our HDD 101 webinar, the fundamentals of horizontal directional drilling operations and tooling. I'm going to introduce who's speaking. We've got Peter Melsheimer is one of our speakers, and Rocky Brister. Peter is part owner and son of Melford Borzall founder Dick Melsheimer, he's been involved in HDD for the past 35 years. His early days were spent educating contractors on what is HDD and traveling the country and even the world to do so. Today, he's aiding the innovative tooling design, and he currently serves as the Vice President of Sales and Marketing here at Melford Borzall. We've also got Rocky Brister. Rocky's got over 20 years of experience working on HDD job sites. He's one of our HDD tooling specialists, and I think it's important to note that before he came here to us here at Melford Borzall, he was a driller, so he knows exactly what's going on the job site from day to day. We've produced this webinar in partnership with the PCCA, and today joining us we've got James Wagner, who's the Director of Membership, Marketing, and Accounting at the Power and Communications Contractors Association. And I'm going to turn it over to James to explain a little bit of what is the PCCA.
Thanks, Josh. Morning, everyone. Since 1945, the Power and Communication Contractors Association has represented the national interests of contractors, manufacturers, and suppliers working in power and communication construction. Our members build and repair broadband networks and electric transmission, distribution, and substation facilities, as well as other utility infrastructure. The PCCA has over 240 members, just about evenly split between contractors and manufacturer supplier members. We hold 2 national meetings each year with industry-focused education and lots of great networking. And coming up next, we have our annual DC Fly-In, April 25th and 26th. At the Fly-In, our top priorities when lobbying the federal government are going to be workforce development, including common sense immigration reform, damage prevention, and permitting reform. The PCCA has its own education and research foundation that has granted dozens of scholarships to the children of our members. It develops curriculum for trade and tech schools, and it facilitates the donation of equipment and other resources to those schools from our members. PCCA works on these issues because they're important for our industry and for our country. If these goals interest you, I hope you'll consider joining the PCCA. I would encourage all of you to, at the very least, check out our website, www.pccaweb.org. Go take a look at our most recent issue of the PCCA Journal, and follow us on social media to keep up with everything we're doing. We're excited to have partnered with Melford Borzall on this webinar and want to thank them for always being a supportive member of the PCCA. So thank you guys very much.
Awesome. Thanks, James. Well, just let me go over just a couple pieces of housekeeping here before I turn the time over to Peter and Rocky. So at the end of this presentation, we will have a Q&A. So if you've got questions, we'd be happy to field those questions and answer those to the best of our ability. How to do that? So in your toolbar, you got your Zoom toolbar, there's actually a Q&A button. So go ahead and press that button and you can ask a question at any time. And so you'll type that question in and we'll either type a response back or we'll save that and try and answer that at the end. But yeah, we do try to reserve quite a bit of time to answer those questions. Also, this webinar is being recorded. So we'll make sure that within the next week, we'll get that recording out to you. So if you got team members or crew that's not able to make it today, you can show that at a later date. And lastly, if you have any technical questions or issues during this, feel free to email me directly, and I'll try and reply back. Be handy on the email here. My email is jparker, Parker, @melfordborzall.com. And so yeah, please use that if you're having troubles, and I'll try and help you out. All right. Well, without further ado, I'm going to turn the time over to Peter here.
All right. Thank you, Josh. Hello, everybody. Wish I could see you all, but hopefully you're there. I just want to thank you all for taking the time to be with us and learn some of the basics of horizontal directional drilling, as well as getting into the details on how the tooling selection can help to maximize your production. So before I get into the how, I want to really impress on you the why, because I know a lot of you are probably new to HDD. So I want you to think about why HDD is important. My brother Eric, the president of our company, Melford Borzall, gave a speech to all our employees just a couple weeks ago. We've been super busy, lots of new employees, everyone doing a good job, working hard to get those bits and reamers out to the job. But he took a moment to stop everyone and make sure they understood the why of what we do. It really had an impact on me and on our entire company. He said that what we do is meaningful, it's positive, and it is very necessary to our everyday way of life and to our future. You're installing the fiber, the duct, the pipes, the cables, everything that keep the lights on and the internet online. It keeps water flowing in and the sewage flowing out. It keeps the heat thawing out during ice storms and the AC blowing during heat waves. It keeps your cars running no matter what type you have. And pretty much it keeps civilization running. So just know that it's very important. Sure, it doesn't all have to go underground, but with the extreme weather, the congested and growing cities, it works a lot better and it looks a lot better when it is underground. All right, so we're going to talk just a little bit about the evolution of HDD. We're not going to dwell on it too much, but I do want to touch on some of the highlights of where horizontal drilling started and how it's evolved. Then we'll get into the now and how we do it now. Understanding where and how HDD started and how it has evolved gives you a better understanding and appreciation of its current state. Plus, you'll be in a better position to help find new opportunities and innovation for growth. So it all really started with taking the principles of vertical drilling and turning them sideways to go horizontally. And really it was my grandfather that and then my father continued that came up with this concept of going horizontally to put utilities underground. The first drill bits, often called fishtail bits, like you can see here on the left, were connected to a drill tube and then spun using a handheld air motor with two really strong workers hanging onto it. Small 2 to 3 inch holes could be drilled up to a house under a road or down a street. And it was hard work, but effective in getting services underground with less disruption. But soon the need grew to go further and install larger diameter utilities. And so tools were developed to enlarge the small 3 inch hole to much larger holes. These were called back reamers because they reamed out an existing hole as they were pulled back towards the starting point. These new needs require the equipment and drilling processes to evolve. Hydraulically powered drill tracks like this, and even walk behind boring tanks like the patented dynamo were built, giving the crews the power needed to go further and bigger and also much faster. So this wasn't a directional process per se, where the bit could be steered remotely as with today's HDD, but the bit could be directed manually from pothole to pothole, allowing for a guided borehole. Then came the means of locating the drill bit. First was the capability to just locate the bit. Not much more than that, but at least you had an idea of if it was going in the right direction, and maybe you didn't have to have as many of those guide holes along the way. But soon the locators and transmitters were developed that could not only give you the location of the drill bit, but also the depth and finally the direction the bit was going. It was these breakthroughs in locating technology that made the first steerable drill heads and directional drill rigs available. From there, it was just a matter of improving the accuracy, speed, and capabilities of the entire HDD process with more advancements in the equipment, the locators, and of course, the tools. All right, enough of that. Now let's get a hole in the ground. First, let's take a look at what typically you'll find on an HDD job site. The primary equipment used on most HDD installs includes the drill rig. So the drill rig is basically the power source for the drilling. The drill bits and the back reamers, which we'll be talking about soon, are attached to the sections of drill pipe on the front of the drill rig. The rig spins the pipe and attached tooling pushes it forward, pulls it back to make the hole and ultimately install the utility underground. But I'm not going to train you on how to actually run the drill rig. Good old Orange and Yellow, they have plenty of cool tools and tech for doing that for you. But then there's the locating system. The locating system consists of a handheld receiver that picks up a signal from a radio transmitter. And this is how you'll find and track the drill bit. Once again, we don't have the time to get into the details of how to use the locator, digital controls, and subsite. They have some great tech for that. But we'll tell you the role the locator plays in the HDD process and why it can be thought of as the left side of the HDD brain, with the information received being very factual and precise. Then you got a mud system usually on the job sites. Most of the time you can't or shouldn't drill with straight water, so you're gonna have a mud mixing system. Typically you'll have a few ingredients that need to be mixed into water for the drilling and back reaming processes. And this is a whole science in itself that we'll touch on a bit later. And finally, you've got a vac. There's always going to be a bunch of mud on the job site when it comes to drilling, because you're using drilling for both the pilot bore and the back ream process that we'll get into. This cool sucker is essential to sucking up all the mud and soil that will be filling up your pits and during the drilling operation. You have to get it out of there before the pit overflows and starts running down the street. But the vac can also serve a second purpose, where it can actually dig potholes and safely expose other utilities, which lessens the need for backhoes and shovels on the job site. So now comes the good stuff, the tools to make the hole and ultimately get those utilities into the hole. The tooling requires you to use more of the right side of your HDD brain. You'll need to be a bit more creative and intuitive, because it's not a perfectly defined choice when it comes to selecting the right bit, which is why we'll be spending quite a bit of time on the tooling selection. But first, let's take a look at a few of the processes of how HDD works. The basics of HDD, they're pretty simple. First step, once all the equipment is set up and the site is ready, is to create a hole going from point A over to point B. It's called the pilot bore. And it's created using a type of cutting bit or blade. Normally these bits are going to cut a hole of about 3 to 6 inches in diameter, but that bit has to follow a predetermined path from A to B, go down to a certain depth and maintain that depth, or move left and right to follow the curve of a road. And it must avoid other utilities that are already underground. Just because the utility is being installed where we can't see it, doesn't mean it can just go from point A to point B in any direction at any random depth. So steering the drill bit up and down, left and right, is accomplished by having an angled steer face on the bit. Normally the drill rig is spinning the drill bit, just like a hand drill spins a bit, and it cuts in a straight line. When you need to change the direction of the bit, the rotation stops and you just thrust or push on the bit. And that thrust with the angle of the blade or the bit causes it to change directions. So the force, the downward force in this example will cause the bit to go down and dive down, change directions. So here's a quick animation showing the drilling and steering process. It's when it's spinning, it's pretty much going straight. But when the rotation is stopped, the drill bit is thrust forward, causing it to deflect. In this case, the bill's on the bottom and it's going up. Now it's leveling out, going down. Excuse me. It's a pretty simple process, but hands-on experience is where you're going to learn how the bit reacts under different conditions. So I know what you're thinking, right? I can cause it to change directions, but how the heck do I know where it is and what direction it's going to go? Well, I'm glad you asked, or I'm glad I'm a mind reader and asked for you. The bit or blade is attached and just in front of a hollowed out steel bar that houses a radio transmitter, which is why we call it a transmitter housing. This transmitter, sometimes referred to as a beacon or a sonde, is like having an Apple AirTag attached to a bionic gopher. It sends out all kinds of information, including the location and the depth of the bit. That information is being captured by a person holding a device to receive the radio signal and all that information that it contains. That's why it's called a receiver. They're going to know exactly where the drill bit is, how deep it is, if it is going up or down, and how fast it's going up or down. Plus, they can tell exactly what position that steering face that we just went over is in, so they can make a change in direction as needed. There you go. You've got the pilot bore completed with a beautiful 4-inch hole traveling over 500 feet at the required depth and right on target at point B, which is the receiving pit. I know what you're thinking again. How the heck is that 8-inch gas main going to fit through that 4-inch hole? Glad you asked. Well, this is where the back reamer is used. Remember, this is a tool that enlarges the original hole called reaming, but it cuts going back towards the drill rig, hence the term back reaming. Once the bit and housing and assembly are removed, the back reamer is attached. Once again, the drill rig is spinning the back reamer to get it to cut, and then pulls it back toward the original hole, cutting it open to the larger diameter that's needed. So during a standard pullback, there will be a pulling swivel indicated here attached to the rear of the back reamer, and then a pulling device with the utility pipe attached to the other end of the swivel. And this all pulls back at one time. The swivel allows the reamer to spin and cut, but not spin your product pipe being pulled behind it. That would be pretty devastating to that pipe. Once the reamer is pulled all the way back to point A at the drill rig, the new utility pipe is installed underground and the world just got a little bit better. Now, you know why HDD is so important, where it all started, and now the process of how HDD actually works. You're ready to go out there and just send it. Installing miles upon miles of fiber optics, electrical cable, and water pipes underground, right? Well, it's not quite that easy. If you want to be productive and successful in this biz, then you're going to need to learn a bit more about drilling. Before I drill into it, how to choose the right HD tools, let me tell a few reasons why it matters. The biggest reason choosing the right HD tool is so important is because it affects your production. You get paid by the foot of pipe installed. If it takes you 8 hours for an install instead of 4, your footage bonus just took a big hit. During the pilot bore, picking the right tool can affect how fast you drill or how well the bit steers. During pullback, it can not only affect how fast you're able to ream the hole, but how clean the hole is, and if you'll be able to get that product pipe back into the hole. Plus, having the wrong back reamer can also result in the drill fluid not staying underground where it's supposed to be. This is called having inadvertent returns, but better known as a frac out. Ultimately, choosing the right tool can be the difference between a successful job and a failed install. In this next section, we're going to primarily focus on selecting the bit for the pilot bore and the back reamer. But there are 3 main factors that have to be considered with HDD tooling selection. First, you have the drill rig size. Then you have the ground conditions, and then the product being installed. So first, the drill rig size. Yep, size matters when drilling. Remember, the drill rig is the power source for the tools, and they're all different size drill rigs out there. Everything from a mini drill for short but quick fiber to the home shots to maxi rigs for drilling under lakes and rivers and even out to the ocean floor. The rigs are commonly classified by their thrust and pullback force and by their rotational torque. In general, more thrust means longer distances. More rotational torque means larger diameter holes. But this means that the same back reamer or bit that is used on a mini rig with 5,000 pounds of thrust can't be used on a large rig with 50,000 pounds of thrust. Just like a hand drill, there are different chuck sizes based on the power of the drill, which means they use different drill shank sizes. The power of the drill rig needs to match with the material size and type that's used to build the tool, as well as the thread used to connect it to the rig. The blades and the carbide cutters need to be thick enough and large enough to hold up to the power of the drill. You can probably get away with using a tool built for a large rig on a small rig, but it's going to probably have to work a whole lot harder. And definitely don't use a small rig tool in a larger rig. It's just going to get destroyed. So now you've worked with your expert tooling manufacturer to determine the best tool build for your drill rig model. What's next? Well, now you got to talk about the ground conditions. This adds another level of a whole lot of fun to installing utilities using HDD. Good old Mother Earth has been around a long time and has quite the variety of ground conditions that you'll have to deal with while drilling. If you're going to drill a hole in her, you're going to have to work for it. The type of bit or reamer you use for your pilot bore is going to have a whole lot to do with the ground you'll be drilling through. Matching the bit and the back reamer to the ground is going to be based on three principles: the cut, the mix, and the flow. So for how a bit or reamer cuts needs to match up to the ground conditions. Of course, you need to choose the right tool so it does not get destroyed in the hole and also gives a decent pullback rate. But the other goal is that you end up with small cuttings. Remember, you're pulling pipe back through that hole. Just about all that soil your reamer cut needs to get out of the hole so the pipe will go in. If your reamer is leaving big chunks of clay or shale in the hole, it's going to be near impossible to get it out of the hole. So when you're trying to decide what style bit or reamer to use, try to think of the cutting action like that of a saw blade. A bandsaw or hacksaw is designed to cut through hard material like, like steel. It has lots of short, closely spaced teeth to give a smooth, even cut. If you start using that hacksaw on a piece of wood or log, you may saw through it eventually, but it's going to take a real long time. In terms of drilling for hard, compact conditions, you want a bit and a reamer with lots of cutter teeth that aren't too tall to give the tool a smooth cutting and grinding action. Let's compare that to a wood saw. It will have taller, spaced out cutter teeth. It needs a more aggressive cut and ripping action. If you use this wood saw on metal, you probably won't even get through it and you'll tear up the saw in the process. Relating this to a drill bit or a reamer, if you're in a formation like shale, caliche, or even clay, you're going to want a tool that can gouge, rip, and fracture. But if you use that tool of this design in something like cobbles, you can tear it up. The other part of the cut equation is the rotational speed of the tool. The speed or RPMs that you rotate the bit or reamer will also be determined by the ground conditions. We're going to talk a lot about these in a couple minutes, along with Rocky, our expert driller. But in general, rotate the tool slower in rocky conditions to help prevent damage to the cutters. Spin the tool faster and softer or compact formations. This is especially important in clay and sand, where you need that tool rotating fast to give a better mixing and pumping action. Again, we're going to get more into the operational details in the next section, but for now, let's look at the importance of the next principle, which is mixing. So with mixing, we're not really referring to the drill fluid mix. That's a whole science in itself. But it is crucial to know that there are different additives that need to be used based on the ground to ensure a successful bore and pullback. A couple examples include sand, where you need an additive to coat the borehole wall so the fluid does not drain out of the hole, leaving it dry with the possibility of collapsing. Clay requires different chemicals be added to keep the clay cuttings from sticking together and from sticking to the tools. Even if you master the drill fluid recipe, that's only half the battle. It won't do you much good if that perfectly formulated drill fluid is not getting mixed up in the hole and interacting with the cuttings made by the back reamer. Remember, the drill fluid and cuttings need to mix together so that they can flow out of the hole. And that's the final principle: flow. You've cut it, you've mixed it, but now you have to flow most of that slurry out of the hole. During the pilot bore, you're drilling with high pressure, about 1,000 PSI, but not a ton of flow or gallons per minute. The high pressure is to help with the bit cutting. You're not making a huge hole, so there, excuse me, there isn't as much material to remove from the hole. That means you don't need as much fluid flow. But with back reaming, the drill fluid doesn't need much pressure because it's not really doing any cutting, but you will have a ton of material to flow out since you're cutting a big hole. So you need a lot more volume of fluid coming out of the reamer. It also helps with the flow if the back reamer is designed to pump the slurry when it spins. Remember, you need to get most of those cuttings out of the hole to make room for the shiny new yellow pipe going in. Deep spiral channels or flutes in a reamer, like this Ogre, pumps the drill fluid to the back of the hole when it spins and allows those cuttings to fly by the reamer. All right, so that's a kind of high-level view of the 3 HDD drilling principles. Now let's get down and dirty and show you some guidelines for tooling selection based on the principles for cutting, mixing, and flow. Here you'll see how the ground conditions affect the tooling selection. We're going to break it down by some of the most common ground types. Now Rocky is going to join us at this point when we're talking about tooling selection to add in some important operational tips on how to be most productive in the different ground conditions. Rocky's been a driller for decades and decades and has a ton of experience to share. And then he's also going to be around at the end of it to answer any of the questions we might have. All right, so we'll start simple. A second here. With some soft soils. This would be good old just dirt, sandy loam, fairly stable, not too sticky, and really a driller's dream. It doesn't happen often enough. For a bit, really doesn't have too much of an impact on the bit selection in soft soils. Just about anything will work, except if the soil is too soft or boggy. You might have to go with a wider blade than normal to get some steering out of it. Because remember, the force of the ground acting on the steer face is what gives it the direction, the deflection. Otherwise, expect the blade to react more slowly when making a steering push. And then in the reamer, again, if you're lucky enough to be in a nice soft soil like a loam, just make sure the reamer has a good mixing action. You might need to add some bentonite to the drill fluid to ensure the hole stays open and doesn't collapse. So then we'll move into something a little more difficult, clay and reactive soils. So they seem easy enough to cut. They are pretty easy to cut, but they can be the trickiest to drill in and pull back through. Reactive soils are when the characteristics change of the ground when it is hit with water. They can swell up around the tool and the pipe and get even stickier. So for the bit, once again, a standard blade will work. Not a whole lot of carbide protection is needed, but it is preferable to use a blade rather than a bit to do the pilot bore, because the bit could have more of a tendency to ball up on you. Now the reamer cutting is going to be relatively easy and not too much wear, but the cutters may peel off chunks of clay. The key here is to mix, 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 and to not have too many solid flat surfaces for the clay to stick to. And for instance, in this tornado reamer, you notice the blades have cutouts in them and they're all angled so that they'll have a good mixing action and not too many solid surfaces for the clay. As the reamer spins, it needs to have a good mixing action to blend up the clay until it makes a smoothie, until it's like a smoothie coming out of your Ninja bullet blender. Too many cutters or blades spaced too closely together can result in the equivalent of trying to pull a doorknob through the hole. So Rocky, what advice would you have for people drilling and back reaming through clay?
Well, clay is one of those situations where you're going to have to observe how the ground reacts, and that's where your mix is going to come in and what kind of reamer you use. One of the things we always talk about when drilling is to observe your cuttings coming back. That's how you're going to determine your rotational speed, amount of water you're using, and how quickly you're pulling the reamer back to the hole. Very important to observe those cuttings on the other side to communicate with your operator what's going on and what the cuttings look like, because you want to remove all those cuttings out as much as possible, especially in reactive soil.
Yeah, and one other thing to touch on is clay can be pretty easy to cut. And so if you have a good reamer on there, it could have a tendency to actually pull back too fast. I know that doesn't sound intuitive, but what'll happen, I think Rocky kind of alluded to, is you'll basically outrun your drill fluid. So you won't have a clean hole. You won't have smooth cuttings that can flow out of the hole. So even though the reamer might want to pull back really fast, you want to give it time to cut, to mix, and to pump that fluid out.
Even on, Peter, even on your pilot hole on the clay, it's important when you're drilling out, doing your pilot hole, that you maintain your flow coming back to the drill. Because that's very important to have that pilot hole to be 100% and open.
Yeah, good point. Yeah, you don't want it to plug off behind the head.
A tendency to drill too fast in clay. That's what a lot of people do.
Yep. And then we come into sand. So sand can seem really nice and soft, but don't let it fool you. It can be one of the most difficult conditions for HDD. Not to mention it can grind down a bit to the size of a nail in just a few hundred feet if you're not doing it correctly. Now, the bit is where you do need to select a bit or blade with plenty of carbide cutters and hard facing. So the hard facing is a material that's applied as a weld bead, and it has a combination in some cases of carbide granules in with the hard facing, and it's applied to the part of the tool that can, show the most wear, and so it can really add to the tool life. For the reamer, same kind of applies, lots of wear protection, lots of carbides. But the other key here is to have a reamer that keeps the cut sand mixed up with your drill fluid. It keeps it agitated, then has a pumping action to keep it flowing out of the hole. If the sand is too idle, it's just going to settle at the bottom of the hole, leaving you with not much of a hole to get your pipe back through. So what do you think about sand, Rocky?
Well, sand's one of those, people make a lot of common mistakes on sand and get themselves in trouble. The first thing they do is drill too fast. The second thing they do is think, well, I don't need to put any chemicals or mixes in. And what happens is, as you're drilling out on the hole, you're not maintaining any flow. All of your water, if you're using a plain water, just going into the sand and disappearing. So we call that a dry hole. It's very important to have a strong bentonite mix that will not be absorbed in the sand. The same thing on pulling back and reaming with that actual reamer. You want something that's going to pack the sand on your way back and give you a nice smooth wall so it doesn't collapse when you're pulling your pipe in. Some of the mistakes people make here is, instead of pre-reaming a hole, meaning you drill out, hook up the reamer, you ream it all the way back to the drill, push it all the way back, that's the preferred method. Some of the methods people do that get them in trouble is where they just pull and ream at the same time, and then there's just too much product. It locks the pipe up in a hole. Now they got a stuck pipe.
Yeah, there is a time to pull the reamer and the product at the same time, but yeah, it's usually not sand or some of the other conditions we're going to get into here. All right, now we're getting a little bit harder and harder here. So next we got shale. There's a wide variety of shales, and some can be hard enough that they require a whole different approach in the tooling and processes, but we're not going to get into those. Those are more like solid rock, basically. But most types of shale can be fractured and broken up. So the bit or the right blade can work, but the right blade can work, but a better choice is going to be a bit like this, a hard soil bit like our U-Claw, which has independent cutters at the front of it. So those cutter teeth can gouge and fracture the shale. Shale is not only hard, but it's also very abrasive. So you want to make sure the body of the tool has a ton of carbide protection all around all wear areas. So Rocky, for shale, what do you recommend here for the pilot bore part of it?
Well, on shale, one of the things you got to think about is you're cutting a heavier product. So now you need to worry about your viscosity on your mixes, meaning you need to physically pick up that product and pull it out. Shell is one of those things, and even more of a rock formation, the same thing. If you don't get those cuttings out, when you're trying to come back, those cuttings are going to lodge around your drill rod and also your tooling. So your mix is very, very vital. The good part is, once you cut a hole in shell, it'll maintain a hole.
Yeah, that's a good point. So now drilling shale, when you're rotating, you got a rotary cutting action is pretty simple, but how do you do it with the with steering? How do you steer when you're up against something solid?
Well, when steering here, like you see this is right now you're doing what's called a carving motion. So you'd be carving from 3 o'clock on the clock face to 9 o'clock. So you're swiping across your product. Now he's in this motion, you're trying to go down. So he'll carve, and then once you get some deflection, probably about 3 to 4 inches, you break it off and drill. So, and then you go a few more and you get another 3% or whatever you're going after on your corrections. But it's a slower process and a lot more technique involved here. It's not just a push. You have to actually use the front teeth on this to carve the hard product and to get your deflection.
Yeah, the good thing in the harder conditions is it doesn't take a lot of penetration to get the drill bit to start changing directions, but it's still hard. You know, it's like you said, it's definitely a technique you gotta master for getting through the harder conditions. And then reaming shale. So now's the time you got to remember or talk about the cut of the tool. Shale needs to be approached with long, aggressive teeth that are able to fracture the shale, but they need to be positioned so there's a gradual increase in the diameter. Otherwise, you're going to be chewing off more than your drill rig can really handle. There also needs to be a lot of teeth. So those shale fragments, like Rocky talked about, are busted up into smaller pieces. Because remember, we still need to get those pieces out of the hole so that the pipe can fit back in the hole. Just knocked over my microphone there. If the shale chunks are too big, you're just never going to get them out. So Rocky, what do you think about back reaming through shale?
Well, shale is an aggressive ground. You need a cutter like this or a reamer like this, excuse me, that has some aggressive teeth on it and is tapered. So that way you could taper your hole out. Also, sizing your reamers are very important. You know, you want to make sure you don't just do one large cut. You want to do a step cut. It's very important because that's going to determine the size of your cuttings coming out. And then your mix makes importance of being able to carry those cuttings out.
All right, now we're getting into sandstone and some other compact hard formations. So the bad news, these compact formations are going to be pretty tough to drill and especially to steer through, just like we talked about with the shale. But the good news is they're hold a pretty nice stable hole once you've cut through them. You're going to need a bit or blade that has an aggressive cutting action, both when drilling and to help with the carving. It won't be quite as tough as shale because you're not really having to fracture or crush the shale as much, but you'll still need to carve for steering. And in sandstone, you'll want plenty of that carbide and hard facing protection on it. And then with the reamer, you'll want to choose a reamer that has a lot of carbide cutters, closely spaced, and a gradual increase in cut diameter. Again, remember the saw analogy with the hacksaw. You're going to want a fairly high rotational speed to give you a good cut and a grinding action. Rocky, how do you approach some of these harder, like sandstone formations?
Sandstone is one of the harder formations to drill in. It takes a little more patience with your corrections, meaning your corrections of, whether you want to go up, down, left, or right when you're steering. So you don't want to be too far off your direction, which way you're going, making corrections. Takes a little longer, and it is a carving motion to get through sandstone. Like you said, it does hold a hole. The good part is you're not moving such of a heavy product out. It's more of a sand style mix. So once you cut it up, you're turning it into sand and not into pieces of rock.
But still you got to get that sand out of there so it doesn't just settle on the bottom of the hole. Yeah. All right, and we save the best for last. This is probably the worst, the cobblestones. Gravel, not so bad much, not nearly as bad, but the cobbles, yeah, pretty bad. It's just tough. Smaller cobbles and gravel might be a little easier, but the cobbles are tough. Remember, the key is going to be to create a clean hole and get enough of the cuttings out of the hole, or at least out of the way, in order for you to pull the product pipe back through. Now with the bit, you're not really going to drill directly through a cobble. Probably not. You might get lucky and break a couple up, but mostly what you're trying to do is to push them out of the way and roll past them. A solid build on the bit with lots of wear protection is going to be needed for it to hold up for the entire bore through the cobbles. But the front of the bit like this, it needs to help roll the cobbles out of the way when it's spinning and compress them into the borehole wall to get the bit and the drill pipe by. So Rocky, why don't you explain how you would, again, steer through it where we've got no rotary cutting action per se, but we still need to be able to make some changes in direction.
One thing to think about is what you're actually drilling through. Most of the time when you hit a cobble formation, it's usually an old riverbed in that sense. So you have a sand and rock formation together, and the rocks are ground to a round rock, meaning you're not going to drill through a round rock. It's just impossible. It's going to move in the sand. So when it comes to our iron fist right here, you're actually pushing the rocks out of the way, left or right, and getting your steering as you go. Because your steering will change drastically because you'll hit a rock and then you'll try to push that rock out of the way with the rocking motion of the bit. So you're dealing with two problems here. You're dealing with the sand and you're dealing with the round rock. What you want to do is get this bit to the other side. Then you want to put on one of our small button reamers that have a domed edge on them cutter instead of a sharp tooth cutter. And you're going to want to bring that product up close to that reamer, as close as you possibly can, pull it back, because your rocks are going to want to fall in on it and wedge against your pipe. But this is another hard technique. I would say cobble is probably the most abusive on drills and tooling. So you take your time on it. Don't get in a hurry on it.
Yeah, good point. Yeah, you got to have patience, a lot of patience in cobbles and yeah, make sure you bid the job right, because you're going to have slower production and you're going to probably be tearing some stuff up.
Definitely more abusive on tooling.
Yeah. Good for us, bad for you. But also it's good to have a solid build reamer, like you said, with shorter conical or dome shaped cutters, but also these flutes can help. The flutes and the reamers, like the previous animation, will help cobbles to get by the reamer, as well as, some are going to get pushed out, some are going to go by. So the flutes really help with that. All right, and last thing, there are some, custom tools that can be made that have a bit of a shield behind them for cobbles. So one like this, again, that has these shorter, a lot of carbides and the deep flutes, but then we have the shield. This is the swivel inside, and then the shield that runs up between the swivel and that gap to where your puller and product pipe typically are. And so that'll make it a smoother transition, so less of a chance for the cobbles to fall in on the product pipe or the gap between the product pipe and ultimately get you stuck out there.
Yeah, cobble's very important. You get that product as close as you can to your reamer.
Yeah, so it'd be like the pipe you're pulling would be tucked up inside there.
Right. Having a built-in swivel on the reamer is a big deal.
Yep. So you're almost there. You have a tool that won't disintegrate from the power of the drill rig. You're able to make a nice clean hole and be productive at it. So what else could there be? Well, now we got to get the product in. So you need to consider what actually is going to go back in the hole. The most important piece of information regarding what is being installed is going to be the outer diameter of the duct or of the package being installed. It's pretty simple if you just got one pipe going in the hole. But what if you're on one of those massive fiber builds where they want you to pull in 10 2-inch ducts and 20-inch-and-a-half ducts? Well, that's a bit more tricky to calculate. There are some calculators out there to help determine the outer diameter of the entire bundle of ducts, but probably it's best to work with your tooling provider, as they can calculate that for you exactly what that outer diameter will be, as well as providing some different ways to pull in a massive duct bundle. So once you know the overall diameter of the product, you need to size the reamer. So a rule of thumb that works well in most ground conditions and up to about a 24-inch pipe or bundle is to use a reamer that will cut a hole that is 1.5 times the outer diameter. That's pictured here. So for example, if you're pulling in an 8-inch duct, you're going to want a reamer that's cutting 1.5 times that, or 12 inches. And then typically with a pipe or a bundle of pipes where the diameter is larger than 24 inches, you want to just go with the reamer that cuts 12 inches larger than that diameter. So if you've got a 24-inch bundle or pipe, then you're going to want to cut about a 36-inch hole. Again, these are guidelines. They're not steadfast rules. And while we're talking about sizing the reamer, I want to point out that you're not always going to go from pilot bore to final back ream and pulling pipe. Kind of like Rocky talked about, excuse me, a little bit already. You might have just got an awarded job for a 16-inch casing, which means a 24-inch hole, based on that previous calculation. But the only rig you have is a 2440. Well, you're probably not going to go from a 4-inch pilot to a 24-inch hole in one pass. So this is where you will probably need to consider pre-reaming or step-up reaming. Basically, this means reaming the hole more than one time. You might pull the back reamer by itself, then pull in the product pipe, or you might need to step up the reamer size each time. First pull a 12-inch, and then put on an 18-inch reamer, and then ultimately a 24-inch with the product pipe. So many of the factors we just talked about, like rig size, ground conditions, and product being pulled back, may dictate how you approach the back reaming and pulling operations. So there you go. Hopefully, those of you totally new to HDD learned a bit more of the magic behind getting a utility underground without destroying a neighborhood or damming a river. And for those of you that have a bit more experience, hopefully you have a few takeaways that will take your drilling to the next level of production and success. As many of you know, or some of you may be finding out soon, HDD is not an easy job to do or an easy business to be in. Lots of variables. And unless you're Clark Kent, you can't see what is going on underground. You'll need to take what you've learned, try to imagine what is going on downhole, and then start getting a whole lot of hands-on experience. But don't forget that what you're doing is vitally important. So the next time the homeowner comes out to yell at you about some drill fluid on their lawn, don't get mad. Just explain to them that what you're doing. Explain to them what you're doing. Show them that you take pride in what you do. And remind them that what their life would be like if you weren't doing it, and say you're welcome. All right. I would like to thank everybody. I think Josh is going to jump in and see if we have any questions.
Yeah, we do here. So we've got, and if you haven't asked a question, you've got a question, now's the time to put it in. Let's see, we've got a couple comments, looks like from Steve Sellenrick. Yeah, and I messaged you back on one of these. We will have a recording of this webinar going out within the next week. And again, if you'd like something, more specific or tailored, just send me an email separately. Let's see. Got one other question from Brandon. What's the newest innovation by Borzal in 2023?
Sounds like one
It's
of
a
our
different webinar.
Oh gosh, we got a few things coming out. Both a lot of it's can't be quite revealed yet, but it has a lot to do with all the fiber that's going on. And we know you guys typically aren't getting paid a ton of money for footage on the smaller fiber jobs. So we've got some tools both on the cutting side and on the pulling side that we think are really going to help your production and make you a little bit more profitable on those. We're always tweaking things. We always like to get back or go out in the field and look at tools, how they're wearing. We're always trying to improve the longevity of the tools to just make it a better value for you guys so they hold up and they don't fail during a bore or something like that. So we're always in the field looking for new ways to even improve just the designs we have out there already. But a lot more coming out this year in the next, I'd say probably a month or two, you'll see.
Great. We got a question from Grady. Looks like a good question about cobble. So where we work is almost 100% cobble. What are the exact bits that you recommend?
Rocky.
What I would recommend on that one is definitely our Iron Fist. Our Iron Fist performs well in the cobble. It helps to maintain your drill rod a little bit, not snapping off bits. Guys have a tendency to put a bit on and try to drill through cobble, then they're snapping bits. they're snapping starter rods, they're snapping rods. Depending what kind of product you have to pull back, if it's a straight pull or not, I always use a reamer with a domed cutter on it, a Packer style reamer, and bring that product up as close as you can. I would definitely go 100% with the Iron Fist. I have several customers that use it in San Diego area, which is a very cobbly area, and they have great success. It's also rebuildable bit too, so if you will put a lot of wear on it, and then it can be rebuilt.
Yeah, Grady, I can't. It's not easy for me to switch over and bring those pictures of those tools up right now, but reach out to us, call or email us directly. Oh, look at that. He's got one.
Right here.
Yeah. And we can help guide you. They're like Rocky said, blades aren't the best because they can get hung up on the cobbles and snap off. Having a more of a solid build bit is much better, like the Iron Fist. But if you need to go with the blade, we can definitely give you some suggestions there. And we have what we call a patented pit bull system for our blades, which lessens the chance of it shearing off in the cobbles. It can still happen, but it makes it a lot stronger than just relying on the bolts to hold it in place.
Also, bring your viscosity up on your mix as high as you possibly can to help maintain that hole open. It won't stay open all the way. You're going to have rocks fall in, but the higher the viscosity and a little bit of lubrication there will always help.
Yeah, and what Rocky is referring to on the viscosity is kind of basically like the thickness of the drill fluid. So that's how they measure how thick or heavy the drill fluid is, and like you said, yeah, you want to have it thick to try and carry more stuff out.
Right.
Great. Yeah, we got Grady also had a question. What are some techniques to improve carving and steering cobble? I think we maybe just covered that.
Yeah, probably more of a wobbling action, again, where you're kind of rocking back and putting my hand in the right place here, rocking back and forth with pressure always on the face, and then just watching your pitch as it changes, and try not to keep backing out and then doing it again, because you'll if you do that too soon, you're going to lose your change in direction that you've just achieved.
Yeah, once you get a change in direction, you're going to want to make a correction right away. Don't let it go too far, because you're going to hit, depending what size of rock you're pushing up against that time. It could be a larger rock, and you're not going to go through it. So you're going to have to work your way around it, over it, or under it.
Great. Gosh, we got lots of good questions here. Let's go with Justin. So when you swap rods on pullback, do you start rotation immediately, or do you dead pull a foot before rotating on pullback?
Well, what I've taught over the years is you want to dead pull for about a foot. Turn your water on, let your water charge up, and then dead pull for about a foot. That way you don't twist up your swivel and your product.
Can you explain what that means, Rocky? Dead pull?
Dead pull is when you're switched out your rod, you're coming down, and you're picking up your rod. You don't want to lock up and then spin at the same time you start pulling right away. You want a dead pull. You want to pull about, people say 12 inches, 6 to 12 inches. Basically, it's taking a slack out between your product and your drill rod.
So you're pulling without rotation.
Correct. But you want to make sure you have your water on and that your water system is charged up, that you are pumping water. So, water on, good little pause, and then straight pull 12 inches and start your rotation.
That's a good safety thing too.
Awesome. All right, let's go with Josh Clay. In some of the reaming photos, you have a barrel in front of the reaming bit. What is the purpose of this, and what kind of conditions should it be used in?
Well, you want to take that one, Peter?
Oh, no, yeah, go ahead, Rocky. That's fine.
Yeah, as far as the barrel, what barrels are used for is to maintain your hole as a round hole and not as an oblong hole. So if your first cut is, let's say a 12-inch, you'll put a 12-inch barrel on, and then now you put your next reamer to step it up to, an 18-inch or a 20-inch, whatever step ups you have. So it maintains that rod off the bottom of the hole and moves it to the center of the hole. So now you're centering your rod and you're cutting a smooth round hole instead of an oblong hole. If your rod sits at the bottom without a barrel, then you're going to cut down. Does that make sense? I hope.
Awesome. Okay, let's see here. Gonna have to field some of these questions here, see if we can get to most of them. Let's go with Darren Hill. Could you elaborate on, elaborate on outrunning your mud? Also, soils change through some bores, and it may be necessary to switch reamer styles based on encountered soils. So maybe you can just respond to varying ground types there within a bore.
Well, chasing the mud part, I'll go through that first. When you're drilling out, it's really important to watch your flow that's coming out of that hole. If you're drilling too fast, you're going to lose flow. So basically, your hole is not moving any product out. Your mud, excuse me, is not moving any product out. So that's, outrunning your mud when you're drilling out. You can do the same thing when you're reaming back. You're spinning too fast and you're pulling too fast and you're only pumping so much mud. Like Peter said earlier, you have to mix this up. So your cuttings need to be mixed up with your mud and then floated out the back. And that's the important part. And what was the other part? I'm sorry.
So varying ground conditions. So probably, yeah, one of the best things you can do there is, because no tool's gonna do it all, but I would recommend staying away from a fluted reamer to begin with, because they're much more limited on, I feel, where they can work. But yeah, they're I don't know. Have you ever gone through a job where, other than like a solid rock job or a became solid rock, where you've had to pull out and switch back reamers to get the rest of the way?
Common switching back reamers. It's on the drill out, knowing what you're going through and what kind. Your mixes are going to make a bigger difference. So, you might be going from a clay to a sand, bottom of a riverbed, something like that. So you might have to switch your mix midway. That's been more common what I've hit. So, if you're running two 1,000 gallon tanks, one set up for clay, one set up for, sand. And sometimes you'll have to switch that. Knowing your ground, you want to choose a reamer that can do a little bit of both. That's something, if you've got a clay and a sand mix, you might want something that's got a little bit of pack on it, different cut. It's just experiencing the ground and see what it does. And your mixes make a big difference whenever you have a mixed bag of soil like that. It's not uncommon.
Great. All right, we got time for one or two more here. Good question. So what if your bore head gets stuck or your reamer gets stuck?
Never.
Well, that goes back to the thing I've been preaching here all along is, when you're drilling out, it's so important to know you have flow. Okay. And that's visually watching the flow. Okay. That way, you're not outrunning your mud. Usually getting stuck is outrunning mud, or you've had a rock fall in, which is, not a whole lot you can do about that. But same thing when reaming back, your locator needs to be watching that flow at the other end and communicating to your operator what the flow's doing. If it's too thin, if it's too thick, if there's nothing coming out, if there's just water coming out, those kinds of things are going to help you from sticking. But generally, if you are going to stick rod or that, what I tell people is bump up your mud a little bit, depending on your situation, push it back gently. If you're in like a rock situation, when I say rock, like a DG or a tighter composite, to move some of that drill cuttings out of the way first. But you don't want to overcharge your hole with pressure either, and you can cause a frack out, or you can hump a road or anything like that. Take your time when reaming. Don't get in a hurry. Don't cut corners.
And sometimes, like having what do they call it, a burp hole or something like that. If you're stuck, sometimes it might be because what they call a hydrolock, and that could relieve some pressure. But yeah, it definitely can happen where you're just stuck and either you dig down to it or you abandon the hole. Definitely happens. But yeah, one of the most important things is watching your pullback speed and your fluid, like you said.
Lower your mud. Very, very important.
Awesome. Thanks, guys. All right, let's take one more. Is there a rule of thumb for ratio of length of bore and diameter of pipe?
Length of bore.
Length of bore is going to be really determined by your machine and how much rod you got on your machine. You can choose, let's say you got 500 feet on the machine, you want your board probably to be about 480. So that way, you got 10 at each end of extra rod, you can work with. Diameter, most of the time has to do with the strength of your machine, the size of your machine, and how much mud you can pump at a time. You can do big bores with smaller machines, but not a long distance, a shorter distance. Because you're limited about how much mud you can pump down hole and to fill up that hole.
Yeah, that's a good point. It's not just a matter of strictly a matter of the torque on the machine to be able to cut the hole, but yeah, you what you're cutting has to get out of the hole for the most part. And if you don't have enough flow from the pump on the drill rig, I mean, you can do an auxiliary to help aid that if you really had to, but for the most part, you're gonna have what you have on the drill rig, and that's what you're limited to. So either you're gonna go really slow to allow the flow to get in there, or you just can't go as far.
And what Peter said earlier about what we call a burp hole in the ground. So if you're talking about a clay situation and you're drilling 500 feet, you're definitely going to want what we call a relief pit somewhere in the middle of there, where that mud has somewhere to go when you're coming back, so you don't build a hydraulic situation, lift on road or concrete or anything you're dealing with.
Awesome. All right. Well, thank you guys for answering those questions, and thanks for those great questions. Yeah, really good questions.
Yeah, and I just want to point out, I mean, that we answered a few questions. I'm sure there's going to be more. This is what we breathe. This is what we do. We have lots of other ex-drillers that work with us as well as Rocky in different areas. All our distributors pretty much have drillers working for them as well. So a lot of knowledge. We love answering these questions. I don't feel like this is your only opportunity. Reach out, call us, email us, whatever. We'll talk, whether you're, in the business or not. If you just have questions, we love to answer them. So give us a call.
Great. All right. Well, we do have a special gift for everybody as you've been with us here over the past hour. So thanks for sticking with us. So we'd like to give you a free gift. So if you go to www.melfordborzall.com/webinar-gift, just fill out that small form there, and we'll send you a free bobblehead, or we like to call it Bobble Fred. And so we'd like to thank everybody for your time. Again, go on, register, get that free gift for spending time with us today. We all had a lot of fun creating this, and we hope you enjoyed it too.
And don't forget to check out pccaweb.org. Great organization, especially with all the power and the fiber going on, that's coming up over the next few years, already going on. They really advocate for that industry and for you guys, for the contractors in that industry. So check it out. It's worth your time.
Absolutely. Yeah. And thanks, James, for being here and representing the PCCA.
Thank you all for having me.
All right. We will make this, again, they'll be recording this. We'll make available, and we'll send that out to all registrants that registered for this webinar. All right. Well, thank you, everybody.
Thank you, everybody.